All right, good afternoon, everyone, and welcome to September's First Friday webinar, UAVs in the AEC, Lessons Learned and How Useful Are They, presented by Matthew Dondanville. For those of you who haven't met me, my name is Ariana, and I'm the Education Specialist with ISPE. So if you have any questions about today's webinar or other education programs, please feel free to reach out. Just a few quick announcements. The handouts and the quiz are available up on our website. You can also find the presentation in the handout section of your taskbar and the quiz link in the chat box. So just be sure to complete that quiz by next Tuesday so we can get you your PDA certificate as soon as possible. Today we're going to be answering the questions as we go. So if you have a question, please type it in the chat box and I will try to read it out loud as soon as I can. So with that, I'll go ahead and hand it over to Matthew.
Welcome everyone. My name is Matt Dondanville. I'm with Hanson Professional Services out of Springfield, Illinois. A little bit about my background. I've been flying UAVs for about 6 to 7 years, but I've been doing photogrammetry off helicopter platforms since before that, and really using the software in agriculture and engineering for all those years. So today we really want to look at kind of some of the best practices Hanson and myself have learned over the years. Most of the people by now have heard about UAVs, are somewhat familiar with the rules. So I'm going to present more of an update, some of the lessons learned and what we see going forward. Some of the agenda items, this will be really quick. You're going to see things on Hanson's drone history, how we personally pick drones, different sensors and payloads, what we've learned, some case studies, and then definitely some about the new LAANC airspace, what's developing in the airspace, what we see other companies doing, and what specifically in the architecture, engineering, construction fields that we use drones for. Our drone history started in 2014. We were flying under the Section 333, and currently today we have 10 pilots. That's actually growing day by day. We've started to onboard and train 2 more pilots within the last week. And we have pilots in Florida, Texas, Illinois, and Indiana. And we've completed projects in over 11 states. I travel quite a lot for UAV projects, a lot in Illinois where we're based out of, but certainly all over the US. The drones that we own, and we'll talk about why we own these drones, are mostly DJI products. While there is a reason for that, we're not tied to one system. We often rent different products, but we find that it's an ease of use thing. It's a knowledge across the whole company, troubleshooting for different locations. As the lead pilot, I have to be able to help people in Florida or Texas or Indiana when they have problems across the corporation. So we've decided that sticking primarily with one drone manufacturer has helped this process. So we'll talk about why we chose that. I've flown over 20 different kinds of drones. So why we pick software versus hardware for the embedded systems of the drone. So let's start with the basics, kind of the hardware of the drone. Everyone, I assume that most people have seen a quadcopter. They sell them at Best Buy. They can be really cheap. But what makes it different, the quadcopter versus a fixed wing versus kind of in the last few years, there's been more of these vertical takeoff and landing, the VTOL drones. There's definitely pros and cons to each. And it really has factored into our decision as a corporation to what drones we want to incorporate in our engineering business. We do all quadcopters right off the bat. So we've looked at a lot of vertical takeoff and landings, and we've flown fixed wings, but as a safety aspect of our enterprise, we've decided that fixed wings aren't right for the kind of work that we do. One of the reasons behind that is safety. We find that the ability to land and come straight down very easily in a very controlled manner is very useful while flying around infrastructure, along the edges of roadways, very much so in a controlled manner, as opposed to fixed wing, where those are great for large open agricultural projects. So there really is no right or wrong drone. It all depends on the situation, and that goes back to why we own 7 drones now, and they all have different applications. So there's no right drone for a project. There's no wrong drone for a project. It really, you have to sit down for each project and weigh what kind of camera, the safety behind the project. Do you need to put lights on the drone for flying at night, et cetera, et cetera. So there's a lot of different aspects to weigh when you're looking at the different kinds of drones. So let's get into how we pick our UAVs. Within the last 2 years, we've had a lot of purchase opportunities where we have upgraded our fleet a lot. That started with us understanding that there's definitely a lifespan to the older technology. A lot of these manufacturers upgrade firmware, and a lot of the different apps that control the UAVs upgrade, and we have to be able to trust the equipment at all times. When you're flying all these different types of projects, the number one most important thing is safety. So the ability to trust the addition of the new technology that we want to upgrade to improve safety, repeatability of the batteries, how long do we need to fly? We were finding that the original UAVs that we were flying with, when we flew these larger projects, the battery life wasn't very good. So we were coming back to switch batteries a lot, which makes the project take longer. We have to charge batteries, but it really puts a safety hamper on the projects, because you're just using more batteries. You're always fighting that battery limit, so you naturally try to push things to the limit to get a few extra photos, and it really becomes a safety concern. So we balance and make grids of how long do we want our battery lives, what hardware and software do we want. I mentioned that we have been sticking with DJI products, and that's just the support of each other's knowledge as pilots, the reliability of multiple batteries, different payload options. One thing about the fixed wing cameras is the fixed wing drones don't have as many payload options. They certainly have more than they used to. People are fitting different packages in them, but there's pros and cons to every different system. So these are some of the many ways that we look at our drone fleet, and we try to have a different tool that can fit a lot of different jobs. One of the drones that we have right now is a caged drone. It has a cage around it, so it can scoot up under bridge decks. It can fly inside of cooling towers at power plants and inside boilers. And it's a very specialty use, but it saves our clients a lot of money. It saves us time, and it really is an increase in safety, since it's very hard to have any problems running with a full cage around the drone. Different sensors and payloads. This sheet is changing faster than anyone can type. Camera technology is getting smaller and smaller. LiDAR units are getting lighter and lighter, and we're putting them on more drones. As engineers and surveyors, the LiDAR and the cameras are certainly the most known. But I was in contact with a integrator overseas within the last week, and they're using GPR on drones, and they're trying to petition the FCC here to let people in the U.S. do that, penetrating and getting water depths and cloudy water and moving water, and all the advantages that GPR has. So there's millions of different sensor packages and looking at what you want to do. One of our most used ones, besides just the normal cameras that we run, is thermal. We end up using that a lot for our power clients, on airports for wildlife monitoring, and then a whole range of other specialty projects that the thermal camera comes in use for. About once a year, on a non-engineering aspect, we get called in for search and rescue using the drone technology and the thermal camera that we have, to find accidents at the lake, on the rivers, drownings, et cetera, et cetera. So all these different sensors and payloads are great for different things, and can be combined to make solutions for clients.
Sorry to interject, Matthew.
Yep.
We have people asking, what is GPR?
GPR, I will go back to that slide, is ground penetrating radar. So it's basically the energy rays that in the US they use it a lot, for sounding and geophysical studies. But the FCC doesn't allow us to fly it in the air right now. And so they're using it a lot in Europe, and we're working on ways to bring this kind of technology to the US, to be able to use it for engineering projects. A lot of what we do at Hanson is around the water. So more economical, more accurate, safer ways to get the depths in water, would be very helpful for our project. So that's one of the reasons that we started looking at it. One question, and a lot of the things I read are, how do we compete with a guy with a drone? As engineering companies, as big corporate firms, versus anyone that can get a Part 107 and start flying the guy with the drone. That really comes into what we've seen is, as we don't really market our drone services individually. What Hanson does is we supplement our engineering, our survey with our drone. That's just what we do, but it is possible. And it really comes down to how people sell themselves. Holding the licensure, holding the insurance is something that's very, very important. And it all comes down to safety of who's the responsible party. What are the accuracy requirements? You're flying a moving vehicle in the air, and part of Part 107 is to help prevent problems with flying and accidents, but things do happen. So what makes people different from a guy with a drone is really the ability to combine the drone technology with survey, with engineering, to provide a deliverable that you can certify as accurate to a certain degree, the repeatability. And then why is the $1,000 drone different than the $15,000 drone? And that really comes down to safety, what we found. The first drones that we started flying had a single battery. We realized that if there's a battery failure mid-flight, there's no backup. The drones these days, they have repeatability in the batteries, their avionics, their flight systems. There's all kinds of backup measures in the more sophisticated drones that really provide that level of safety that we want for our liability, but the clients are also demanding. Are there any questions before I go on?
Looks like we don't have any more at this time.
Okay. So let's talk about what we're seeing in the airspace. We started, and I'm not going to talk about Part 107 a whole lot because it's been around for a few years. I'm sure there's a lot of people that already fly, and a lot of people talk about it already. So Part 107 is where it started. It started before Part 107, but Part 107 were some of the very early regulations of how to fly, what's safe, et cetera, et cetera. What we're seeing now is more authorizations and waivers daily to the Part 107 rules that allow people to fly at night, to fly over people, to fly beyond visual line of sight. And then recently, at the beginning of this year, we'll talk about, and one of the quiz questions is about the Low Altitude Authorization Network, the LAANC system. And I've had the opportunity to fly under the system a lot, so we'll go into details about how that's helping the industry, how it's making things loads faster on the authorization side, about flying safely near airports, which happens to be where a lot of the projects are. A lot of our projects are around cities because they're intersections of streets, they're cell phone towers, they're railroad tracks. The likelihood that it is by an airport seems to be pretty high. So safely and efficiently including airspace authorizations into our projects is something that has really developed and advanced in the last year. So again, I'll talk about some of the quiz questions. This new LAANC system, you can get automatic authorizations under the LAANC system, and you can get them instantly, and you can request variations to those, and sometimes get them granted within 5 minutes. So it really is making flying near airports in some of these pickup projects that we're seeing a lot more efficient and a lot safer.
Matthew, we have a quick question. Someone is asking, what is UAS?
UAS?
Yes.
So some of the basic terminology, and I apologize, I use the UAS, UAV drone terminology pretty interchangeably. UAS is unmanned aerial systems. SUAS, which you'll see quite commonly, is small in front of that. And then UAV is vehicle, and then a drone. So a lot of people use these words interchangeably. They all mean the same or very similar. But the industry has tried to stay away from the word drone, because when drone technology was very new for the consumer and commercial, people thought of the military drones, and so that's how the terminology developed over the years. So building up to the LAANC system started with Part 107, like I said, and part of Part 107, which includes rules about not flying over 400 feet, flying during daylight hours, not flying over people, not flying close to airports, and being within visual line of sight. They developed that system that requires pilots to be licensed. So UAV, UAS pilots to be licensed through the FAA. So a lot of people have gone through that step, and then there was a process to petition for projects that are close to airports, for projects that require flights at night, and any of these rules could be petitioned, and that's the building blocks to this automatic network control that the LAANC system is. One of the questions is that what is the most common waiver granted by the FAA, and that would be night flights. I read a report the other day that 96% of the night flight waivers that have been submitted have been granted. So So while it is part of the Part 107 rules, you can fly projects at night. You just have to petition the FAA for a waiver saying these are the safety measures I'm going to take to be able to fly at night. Other ones that have been granted are BNSF has waivers and have been testing systems to fly 400 miles at a time with a UAV that's larger than 55 pounds at night, and various other waivers. So the FAA is handing these out. But the next easy step is this LAANC system. So I'll go ahead to that. The LAANC system is derived off of what the FAA calls the facilities grid map. And that's a GIS map that shows what the recommended UAV altitude is around airports. It specifically does not authorize operations, but it's a guide for submitting these FAA waivers, the FAA authorizations, that guides you to say, you know, if you want to fly up to 200 feet in this little quadrant, then if you present the right safety measures, it will probably be granted. But you always have to go through that authorization first. So the LAANC system takes that further. The LAANC system is the system that communicates directly with the airports that gives these automatic authorizations. So I can request an automatic authorization through the LAANC system, which is provided by 4 different vendors: AirMap, Skyward, Project Wing, and Rockwell Collins. You can log onto their website, request automatic authorization around certain airports, and it can be granted instantly, and the air traffic control at the airport finds out that there's going to be a UAV mission instantly, and they know exactly where you are and what grid at all times. I'll give a case study of this. In Springfield, we work on the Springfield Rail project, and I was asked to do a video mission for project documentation throughout the whole city, from the south part of the city to the north part of the city. I had to get my LAANC authorization, which included some automatic and some that was too close to do the airport. So I petitioned to have a review of the LAANC system to fly at 150 feet, which took a few days, but I did get that authorization, and it's a lot better than waiting the 90 days plus for traditional waiver or authorization. And then we'll talk about later about some of the other safety practices that we go through. I talked to the local jail to inform them. I talked to the local hospital and was in constant communication with both the airport, but also in direct communication with their life flight system to have real-time communication with all these different partners, just to provide that extra safety measure on top of the LAANC system and what the FAA requires. But I ended up flying multiple missions because of line of sight issues, but I ended up flying 15 miles through downtown Springfield. So it is possible to do these projects, and the LAANC system definitely makes it easier. It took me about a half hour to get all these authorizations, as opposed to 90 days if I had to do a project-specific authorization. So this FAA, the point is the FAA is working to make flying easier for all projects, for all people. It has been slow, but this LAANC system is very impressive to me and has helped out our process a lot. Are there any questions?
Matthew, you may have already answered this one. Someone has asked, what does the LAANC system mean?
So it's the low altitude aerial network. I think that's correct. It's basically the system. It's the low altitude automatic. So it automatically can provide authorizations to fly within 5 miles of an airport. It's not every airport now, but it's quite a few airports in the southern part of the state. And coming September 15th, Wave 6, September 13th, will be a lot of the airports up around the Chicago area, authorizing, and basically what it does is it authorizes you through your submittal that you can fly up to 200 feet in some grid areas, 150 feet. So you can fly a lot closer to the airport, and it provides an extra level of safety because the air traffic control at that local airport knows exactly where you're flying, when you're flying, et cetera, et cetera. So if we move on to a very frequently asked subject about UAVs, and it's the topic of accuracy. It's getting better. There's more information, more people have done the research, but there's a lot of factors. And that comes back to the same idea that I spoke earlier, the guy with the drone versus an engineering company or a surveying company that uses drones to aid what they traditionally do. There definitely is an easy way to fly a drone, but there's a hard way to get very accurate, very good data. So the slide shows many of the different risks, or not risks, but many of the different factors that go into the highest map accuracy project that you can have. Camera technology plays a huge role. It's the cameras on the little drones look amazing. They're great, but there's certain internal components, internal calibration that doesn't always make them the best for getting the highest quality and the best accuracy. Image overlap is when you're planning a mission, there's image overlap that can be stitched together, but it doesn't aid as much in the accuracy as if you have over 75% overlap. So that's a quiz question right there, is that for standard 2D straight down mapping, the recommended overlap is 75%. There's a lot of suggestions that take that to another extreme. 3D projects require over that, but that is what we have found. That's what a lot of the research says, is at least 75% front and side overlap is very important. It is possible to stitch with 60%. You're just risking not being able to stitch when you come back in the office. Other things that play a huge point is the accuracy of the UAV itself. Each photo is tagged with a GPS location, and when it goes into the software and tries to line up all the pictures, if you have a drone with not a very good onboard GPS, it's going to have problems and going to affect the accuracy. Ground control points. This is another big one, that if you don't have the equipment, as with, like I said, the guy with the drone, it doesn't have the equipment, placing very accurate ground control points can ruin the validation of a project. It goes more into a relative model as opposed to tied down to real life coordinates. And then what you use for that. Are you using an RTK GPS to shoot ground control points, or what technology are you using? All plays a part. And then finally, there's over 25 different software that people commonly use, and it's really not all built the same. Some software has better algorithms for AT, which is aerial triangulation, one of the basic principles of photogrammetry. Some software counts for GPS drift. Some software calibrates the internal camera properties automatically, and some requires input. And there are some softwares that don't use the GPS at all. So when you're developing a program or expanding on what you currently have, there's so many components to what makes a project successful on the accuracy standards. Going a little bit more on the accuracy topic, it really comes down to tying it down to the earth. As engineers and surveyors, software providers, companies that sell hardware, people often overstate what drone accuracy can really get to. Will you ever get perfect centimeter grade across the whole site? No. Is it really needed is the question. The thought logic there is, what can a surveyor do on gridding out a site? Is it for phase one? What kind of accuracy do you really need? The drone photogrammetry collects so much data that you're really getting a data point per pixel, which can be in the centimeters. So it really fills in nicely between and complements what surveyors and engineers do. I wrote down here some of the checkpoints, which are ground control points that you don't use to tie down the project always. You use them first to check to see if the software is close. Is it within your project parameters? So you want to always make sure that you do have plenty of checkpoints that you can check your project against. I can't say it enough. The drone never replaces traditional survey for engineering, for planning those kind of missions. It only aids, it fills in data. So what is the accuracy of the GPS that you're using if you're using a GPS to shoot in those ground control? So the thing that people always want to hear is, how accurate can it get? It can never get over 2 times your GSD. Your GSD is your ground sample distance, so that's how big your pixel size will be. For example, the drone that we fly, each pixel will be about 1 inch at 400 feet. So that's at 400 feet. If I'm flying 400 feet, I would never tell anyone that we can get better than 2-inch resolution. And that's across the whole project site. There might be some that line up better, some that line up worse. But the moral of the story really is what do you need for a project? For what you're using the drone for. And this is the most important thing to keep in mind is, are you trying to get rid of surveyors? Because that's not going to happen. What accuracy do you need? Are you going to use it for phase 1 studies? Are you using it for projects that need GPS accuracy at all? Or are you just doing project documentation? So not overstating what the drone can accomplish on the accuracy side, but realizing the limitations and then saying what benefits it has on top of those limitations. So, are there any questions?
Looks like we don't have any at this time.
Okay. So we'll talk here about some of the real world examples that Hanson has seen. Some of the different projects that we've done. We've done hundreds and hundreds of projects with UAV over the years. But really, what are the different categories of projects? I was talking accuracy there. If you think about all of the projects in the AEC realm, there are plenty of projects that you don't need highly referenced, very accurate photos for. Pictures. We just took photo documentation of a old bridge that in Meridosha, Illinois, that we blew up. And so photo documentation, construction observation. We have projects that we fly once a week, once a month. Asset inspections. We do a lot of power plant work. I mentioned the cage drone that we fly inside and outside of the cooling towers, inside the boilers, on the undersides of bridges, just to do visual inspections. And then also, we're doing a lot of virtual reality for public engagement, where we can show existing conditions and how the new traffic roundabout or the new building looks inside before it's even started. And then there's the idea of referenced projects, updated ortho imagery. People ask, is the drone really worth is there the return on investment there? And what I always say is the updated ortho imagery is worth it if that's all you do with it. Going out a week before you start a project and having just the photo documentation of new imagery. When they're drawing CAD, why not draw it on top of the most updated imagery? Other projects are cut fill surveys and full surveys. So the full survey is blended with traditional survey, but it's filling in those data gaps in between the traditional survey spots. I mentioned earlier that there is a big cost component and a project success component of what software you're using. There's software that is all in one. It kind of takes you through flight planning to processing, and there's software that processes online. But it doesn't, some of those softwares don't give you the checks and balances to change parameters if a project fails, or to really do the QA that you want to do. And at the bottom, I say blended data sets. And really what comes with these softwares is what's the deliverable. Most people don't want all the data. It's really cool to see, but they want the cross section still. They want to merge in the traditional survey. They want to blend in total station scans. So these blended data sets of, yes, we're doing really nice photography and getting a point cloud out of the drone data, but what does the engineer want? What does the client want? What does the surveyor want? So there's different software suites for each of those. And we actually run 4 different softwares depending on the project for processing drone photography. Just for a quick example, this is one of our blended data sets that we do, that we've done for projects. And it is, we fly it with the drone, we shoot it with a total station and do traditional survey. And then we blend in the CAD data and the Vism microsimulation modeling software to get accurate traffic representation. Granted, not everyone in Peoria, Illinois is driving a Lamborghini, but it really does give the client and the public an idea of what a roundabout in this intersection might look like. And it makes it easy with all this data already collected to see the different options, a 4-way stop versus a roundabout, and really get that public involvement. So the UAV for engineering is not just collecting imagery to use behind a CAD. It can be used for a multitude of other things, including public involvement.
Matthew, we have a question.
Sure.
What is a Class C airport, and can you fly over it?
So yeah, that's one of the quiz questions that I was going to highlight at the end. So the Class C airport, when you take your Part 107 exam, you would learn a lot about airspace, reading sectional charts. The Class C airspace is one of many different classifications, going from, there's B, C, D, E, and G airspace. You cannot fly next to Class C airspaces without an authorization. It's an FAA regulated airspace. It is an airspace that you can petition the FAA through the LAANC system if it's available, or through a regular authorization or waiver to fly next to. But you can only fly, you cannot fly by Class C airports without FAA exemption, you can fly by Class G airports. We do a lot of airport work. There are airports that you can fly by with only the permission of the airport administrator. So the answer to that would be false.
We have another question.
Yes.
Is LiDAR preferable to photogrammetry?
There is a astronomically high cost to LiDAR, and what we've seen is it definitely makes sense on certain projects, and it doesn't make financial sense on other projects. With LiDAR, there's a very high initial investment. There's a very high cost of data processing, etc. There's just an overload of data. LiDAR does great, even on drones, over trees for giving really sharp edges. But really penetrating trees is where it comes in to the greatest benefit, because photogrammetry can't see through trees. So I would say for 90% of our projects, we do not fly LiDAR. The need is not there. The very, very precise, accurate points that you want to tie it down to, photogrammetry can get what we need for what our projects are asking for. And only in very specific uses do we want to fly LiDAR off the drone. Your drones can easily get up to $200,000 if you put a LiDAR unit on them, and there's a calculated risk there of do you want to invest in that, and do you want to put it up there? So yeah, overall, it's not necessary. What we are doing is we're flying photogrammetry and blending it with ground-based LiDAR data sets in most of our projects. We can go out and use a terrestrial LiDAR scanner and blend it in the software to produce a really nice data set. So if there's no more questions right now, I'll go through a quick example of kind of planning and what we see in our projects. I've flown projects.
Sorry, Matthew.
Yep.
Before you get started on that, we do have one more question.
Sure.
Have you come across cooling towers that needed repairs? If so, could you give some details?
Yeah. So we have flown cooling towers, and what they're looking for. They've been flying the outside for a while, but the cage on the drone provides us a safe way to fly the inside. And what they're really looking at is tuck pointing at the very highest part of cooling towers. If there's mortar going to fall out, if there's a loose brick, for damage and for safety of the people and the equipment below. So the cooling towers are really a visual inspection. It is possible to take enough photos to do a 3D model, that you can have a 3D model of your cooling tower and identify exactly what brick it is, to see, is there a temporary solution? Does it need to be fixed right now? A lot of the power plant solutions are just visual. The boiler inspections, they have to do inspections inside their boilers once every 3 years. So there are a lot of places that we're seeing the drones being used to save them a lot of money, and really to make the inspection safer. So one of the roadway projects that we've done, I was going to say the largest projects that we've really flown in with the drone is I've done 4 square miles over 2 days for some topographic analysis and updated imagery. And then the recent flights that I've been doing in Springfield for the rail corridor have been about 10 miles. And I can do those in a few hours. With the visual line of sight, you have to do a lot of pre-planning and set up and leapfrog your operations. But these large projects are very easy to do with the drone. This is a project in Dondanville, Illinois, that we got updated imagery and some fill into the survey that we've used for a sanitary sewer upgrade. We did 4 different missions here. We have the times on there. new technology. This was done with one of our older drones. Our newer quadcopters can go about 45 minutes, so we wouldn't have needed as many flights, and it really speeds up the process. We did control points on what the surveyors already surveyed. So they already surveyed the storm sewers, some monuments, manhole covers, and so we could use those for our control points, our checkpoints for this project. This is an example of the ortho imagery that IDOT provided us and what made us want to use the drone on this project. I mentioned earlier that the return on investment can be found just in the updated imagery. Here's the IDOT aerial image that they provided us for the area. The downloaded NAPE imagery for the area. Google Earth, which is hard to pull into certain softwares because of the copyright. And then our UAS imagery. So just going out there and getting imagery right before the project is a huge benefit for checking your CAD work and just locational awareness in the office when you're designing these projects. You can see here the ortho imagery and what we're able to extract and check against the edge of curb, backstops, overlaying your CAD and just doing, it's an extra QA measure. And then here's an example of some of the 3D products that we can extract. 3D point clouds that look a lot like LiDAR data sets. You have to make sure that you note if they're georeferenced properly, how accurate the survey is, because they're not LiDAR data sets, but they're both point clouds. You can cut cross sections across them. You can develop contours. It all depends on what you need accuracy-wise, if you trust your UAV data after you process it, and it's really putting that stamp of approval that an engineer or a surveyor has behind the product that you're collecting. Here's a video that we have for public involvement. That's another example of just the use of the UAV. You have the technology. It's fairly cheap, just providing services that you get a different view for public safety for these projects. And sometimes we use it just as a volunteer or public relations with some of our clients where we have the technology, we know how to run it. Do they want to do something for advertisement or marketing? While we're engineering and survey companies, there's some of this added benefit of knowing the technology that we can provide our clients. And then now that we're getting towards the end, there are a million other uses for the UAV. Like I said, we've done hundreds and hundreds of projects. One project that I'll highlight here that is on the quiz is, and I know there's questions about this question or the statement is it is possible to fly over 400 feet without notifying the FAA, and that is if you are within 400 feet of a tower or a building that is above 400 feet. So I've flown an 1,800-foot TV tower for inspection purposes to fulfill that criteria where I didn't need to inform the FAA because of that exemption, that rule stated in Part 107. We've done a lot of airport analysis, quick documentation of landslides, our electrical, we talked about the cooling towers, a lot of inspections that way. The airports are using the technology to do localized tree clearing at the end of approaches, where we can fly and get the elevation of the tops of all the trees and say, we just need to trim this tree to get it out of the path of the airplane. Wildlife management and disaster relief. There's a million uses. I can't know all of them. We rely on the engineers coming to the pilots or the clients coming and saying, can we try this with the drone for a lot of these? And then let's wrap up with what we see coming in the future. Automation, better sensors is the biggest one. Drones that fly longer. There's 120 megapixel cameras that people are flying, and they can see worms at 400 feet. It's crazy. I mentioned earlier that BNSF is flying 400 miles at a time, and they have machine learning algorithms that can automatically see if the railroad ties are not straight or if there's a problem with the railroad ties. One of the ones that we're investigating a lot for our power clients is flying for vegetative management multiple times and having the algorithms automatically calculate how much the trees are growing over a 6-month period, and doing a very rough estimate of, all right, you might have to cut this tree in 5 years. You might want to budget for it. And doing over a whole network, you can predict these costs for years out using drone technology. So that brings us to the end. I'm happy to have questions. And yeah, so any questions? Again, my name is Matt Dondanville with Hanson Professional Services, and I can certainly provide my email to anyone that has questions off the webinar.
All right, Matthew, thanks for that. So we do have a few more questions I'm just going to run through.
Sure.
First one, does the survey equipment determine the shortest GSD for a project?
The drone is the ground sample distance for the project comes from what camera you have on the drone and what altitude you're flying at. The lower the altitude and the bigger the sensor, at about 200 feet with the drones that we're flying, your pixel size will be in the centimeters, 1 to 2 centimeters. So your GSD all comes from the camera in the drone. It is definitely not a matter-of-fact aspect of this is definitely what you're going to get accuracy-wise. It's just a quick calculation is you can never get better than 2 times the GSD. So it does not have to do with the survey equipment. The survey equipment is definitely part of what plays in if you weren't doing the quick calculation. When you start looking at things like overlap, the survey equipment, how windy it is, the clarity of your pictures, those all play a factor when you're looking at the actual accuracy that you think you can get on a project.
Okay, next question. Is it 400 feet of the tower? What about guy wires? They can extend out further than 400 feet.
So that 400 feet is not just a tower or building, it's an object. So you can be within 400 feet of the guy wires. I will say that flying towers is one of the more nerve-wracking things that I've ever flown, because you do have to watch out for those guy wires. They come out, but I will say typically when they come out, by the time that they're 400 feet off the ground, they're usually less than 400 feet by the time you're 400 feet out. But yes, it is okay to fly around a tower like that.
Okay, next. Can you legally fly over 400 feet if you are within 400 feet of a building / tower?
Yes. So the theory behind that is buildings and towers that are that high are on FAA sectional charts or have FAA lighting around them already to warn manned aircraft. Manned aircraft are supposed to stay well above that 400 feet anyway. A lot of times when you're flying, what you need to look out for are low-flying helicopters which are supposed to stay outside the airspace as well, but we fly next to hospitals sometimes, and you have to watch out for low-flying light flight helicopters and low-flying aircraft. So the FAA has designed that 400-foot airspace to make a barrier between drones and manned flight, but there are special exemptions that's the reason that you always need to be within visual line of sight without an exemption and to really have situational awareness of your drone mission.
Okay, we have someone asking if you could go over question number 2 again, which is you can fly drones on Class C airports with the permission of the airport administrator. They're
Sure.
wondering why the answer is false, and if you could maybe expand on that.
So the answer to that would be false. That would be, it is false unless you have a authorization or waiver from the FAA. The permission of the airport administrator alone does not give you permission to fly around airports unless it's a Class G general or Class G airspace that do not have the boundaries or the limits around them. So yes, it would be false unless you have specific FAA authorization on top of that.
So you may have answered this one. Someone is wondering, can you fly at any altitude as long as you stay within 400 feet of a building or tower?
I have not seen, I've flown at 1,800 feet next to a tower. I don't think there's any rules. I mean, if there's a mile-high tower, I don't think there's a clause saying that there's a maximum altitude around that.
Okay, and it looks like our last one, what are the wind restrictions when you are flying for aerial inspections?
The wind restrictions, it says in Part 107 more about clouds and drone speed. Wind restrictions are based on the drone, what the drone is rated for. I've flown in 40-mile-an-hour winds, and with a good enough camera and gimbal stabilizer, you can get decent aerial photography. So it's not as much a regulation from the FAA as to the calmer the winds, the more stable your camera is going to be, and the clearer the pictures will be.
Okay, so I hope that I asked everyone's questions. If I did miss your question, Matthew, is there an email they can reach you at?
Sure. I mean, I can say it or we can send it out, whatever's easier.
I can go ahead and, if you want to say it, but I can type it in the chat box so that they have it written.
It's M. Dondanville, my last name. So MDONDAN, B as in Victor, ILLE, at Hanson-Inc.com.
All right. We did have a few more questions just come in actually while that was going on. I'll just go ahead and read them if you don't mind.
Sure.
We have someone wondering, how much is the average battery life?
The average for quadcopters can get up to about 45 minutes. We have battery sets that are 45 minutes, but that's about the top. What we do is we have 6 sets of batteries, so we can run them in succession and charge the ones that are dead. While we're continuing to fly, it takes about an hour to an hour and a half to charge most batteries.
And then the last one, would you give us an example of an accident you may have experienced?
Yes. So when we started doing tower inspections, we had problems with radio interference frying the electronics of drones, which is why you don't fly above people. So accidents do happen, unforeseen circumstances. Flyaways do happen. So writing your company's procedures of what happens if there's a flyaway, how do you recover? Most of the time it's just intermittent signal loss. But when you're flying in downtown environments, there's more metal buildings, there are more tall buildings. Your radio range of what the manufacturer says for a drone is not even close to what they say sometimes. You can get into interference problems, and having procedures internally for that is how you can mitigate that.
Great, thanks so much, Matthew. So before we sign off, I'll just have a few more announcements. First, thanks again for a great presentation. We had 110 people registered for this webinar, which is really exciting. So I just want to thank all of you for attending and asking a lot of questions. We really appreciate it. I just have a quick reminder. We're having a virtual SE boot camp this year, and we're kicking that off with October's First Friday, which is the HS Pedestrian Bridge Project with Warren Fiorito, who's also from Hanson. So if you're an SE or if you know an SE that might be interested, we're going to be hosting webinars once a week up until license renewal. So keep an eye on our website for more information coming soon about that. Don't forget to complete the quiz by next Tuesday so we can get out your PDA certificates. And thanks again, everyone. I hope you have a good weekend.